All right, welcome to moles conversions worksheet number 1. For this, you're going to need a periodic table and a calculator. So if you don't have those, make sure you get those out. You can pause the program while you do that. All right, and then what we need to have a little background is that moles, well, we're calculating a bunch, is equal to mass, and that is in grams, over formula weight, which we use the periodic table to calculate. And the first question says, convert each of the following either to mass or to moles. And so if I'm given grams, I'm going to put grams up here on the top. And that means I'm obviously going to calculate my moles. So the first one thing I'm going to do here is I'm going to say I want to find moles because I'm given grams. And I'm going to put my mass over, and now we have to calculate a formula weight. So the way that we're going to calculate the formula weight is with our periodic table. I see that I have calcium. If you look up the atomic mass of calcium, it's 40. And I have 2 chlorines. And if you look up on your periodic table, chlorine has an atomic mass of 35. So to get my formula weight of calcium chloride, I'm going to do 140 plus 35 plus 35. When you add that up, you get 110. Now we are going to divide, and when I divide 2.62 divided by 110, my calculator spits out a number I'm going to round to 0.024. Then, if I'm finding moles, I need to write moles, and then it's good practice to write what you found moles of. If you get moles, I am going to put it on the outside where this moles is, and that means I want to find grams, which is on the top, and I still need a formula weight. I have 1 sodium at 23, I have 1 hydrogen at 1, I have 1 carbon at 12, and I have 3 oxygens at 16 apiece, so 16 times 3 is going to be 48. I'm going to add 23, 1, 12, and 48, and I'm going to get a formula weight of 84. Now, algebraically, you can think if you're cross-multiplying, but the idea is that we're going to multiply these two together. So in your calculator, you're going to do 1.23 times 84. Your calculator is going to spit out 103.32. And because I'm looking for mass, the unit I want for mass is going to be grams. And then again, it's good practice to write what you are trying to do, or what you are calculating for. Now, there's a couple more, so I'd like for you to pause the recording now and try the next 4 on your own. All right, let's go ahead. So I'm given moles, so that's going to go on the outside. I want to find mass. 1 zinc, 2 chlorines is going to add up to 135. When I multiply these together, that's going to get me 75.60. Because it's the top, I know that is grams, and I'm going to write what that is. If you haven't paused it, go ahead and finish these up on your own. If not, let's just keep going over them. This is grams, so I'm going to write 12.40 over the formula weight of 1 carbon and 2 oxygen, so 12, 16, and 16 is going to be 44. And I'm going to divide these two, and when I divide them, the calculator spits out 0.28. I need moles carbon dioxide. If you haven't paused the program and try these on your own, I'd say try to do them now. If not, let's keep going. I'm going to go 0.96 is my grams, and I want to find moles. 1 barium, 2 nitrogens, and 6 oxygens is going to add up to 261. When I divide those numbers in my calculator, you should get 0.0037 rounded moles. Again, that is a required unit of barium nitrate. The last one over here, I'm given moles, and I want mass, and this is of calcium, oh, that looks weird, hydroxide, and this should be OH. That is 74 for 1 calcium, 2 oxygens, 2 hydrogens, and that's going to, when you multiply these two together, that is going to get you 5.03 grams of calcium hydroxide. All right, the next step on this worksheet, it says how many moles of each element are present, and it's already in moles. So what I'm going to do is I am going to they are able to talk to each other because they're both in moles. If I want moles and I have them in moles. And in the lecture, we talked a little bit about these cheese sandwich idea. And if I have a cheese sandwich, and in my cheese sandwich, I have 2 pieces of bread and 1 piece of cheese. If I have 10 cheese sandwiches, I actually have 20 pieces of bread and 10 pieces of cheese. And what I did was I took my subscript and I multiplied it by, and there's always assumed a 1, and I multiplied it by how many I had. So as long as they're speaking the same language, they're both in moles, okay? All I have to do is multiply my given by the subscript. So let's figure it out. If I have 360 moles of water, I'm going to multiply that by 2 for hydrogen. I'm going to multiply that by 1 for oxygen. And so it's in moles, so I get moles. Let's try the next one here. 34 moles of NH3. I'm going to multiply that by 1 for nitrogen. I'm going to multiply that by 3 for hydrogen. Okay. I would say pause the program here and see if you can't finish these by yourself. All right. Hopefully you gave them a shot here. Let's go ahead and take a look. So if I have 10 moles of sodium bicarbonate, I'm going to multiply that by 1 for my sodium, 1 for my hydrogen, 1 for my carbon, and by 3 for my oxygen. Let's try to see what we got going on down here. So if I have 9 moles of H2SO4 and I want moles, I'm going to go 9 times 2 to give me moles of hydrogen, times 1 for sulfur, and times 4 for oxygen. Okay, now the next one we have here, 50 moles, and I want moles. I'm going to multiply that by 1 for calcium, by 1 for carbon. I'm going to multiply that by 3 for my oxygen. And the last one, if I have moles and I want moles, speaking the same language, I'm going to multiply the 5 aluminum nitrates by 1 for my aluminum. I got 3 nitrogens here, and I have 9 oxygens there. All right, let's get to the back. All right, so with our periodic table and our calculator, we are now talking about how many grams of each element are in the following compounds. So sometimes students say, all right, well, this is easy, as this is moles to moles and this is grams to grams. This must be speaking the same language as well. And that's not true. The problem we have is that iron has a formula weight of 56, while oxygen only has a formula weight of 16. And we can't necessarily compare those in mass because one is so much bigger than the other. However, what we can do is we can compare them in moles, like dozens. So we can't compare ostrich eggs and chicken eggs in pounds, but we can compare them in dozens. So what we have to do, whenever basically you see grams, you should be itching to divide a mass by its formula weight to try to put it into moles. So what I'm going to do is I'm going to take 14.4 grams, and I'm going to divide it by 2 56s and 3 16s, and that's going to be a formula weight of 160. When I do 14.4 divided by 160, my calculator tells me I got 0.09 moles of Fe2O3. Now I know basically how many dozen I have of each, and then I can pull them apart and compare them. How I'm going to do that is I'm just going to do the scale we used right over here. If I had 2 hydrogens, I would multiply that by 2. 1 sulfur, multiply by 1. 4 oxygens, multiply it by 4. So what I'm going to do is I want moles of iron and moles of oxygen. So I'm going to multiply my iron by 2. 0.09 multiplied by 2 is 0.18. I'm going to multiply my oxygen by 3 to get me 0.27 moles. Now I know how many moles of each we have, but I don't know how many grams of each we have. So what we're going to do is we are going to do another moles equal mass, what I'm looking for, over formula weight for each of these compounds. So now I'm going to put this over X, and I want the formula weight of 1 single iron. We already accommodated the fact that there were 2 of them, so now we just need 1 single iron. Here, I'm going to do mass over formula weight of 1 single oxygen, which is 16. When I multiply 0.18 by 56, I get 10.08 grams of iron. And when I multiply to 0.27 by 16, I get 4.32 grams of oxygen. So now we're moving on to the next one. I would say pause the program and see if you can't figure this one out. All right, so let's take a look. Again, we have grams and we want grams, but we can't compare grams because that's not talking apples to apples. We have to get things into moles. Then we've taken into account their formula weight and we can compare them. So the first thing I'm going to do is I'm going to take my mass, which is 154, and I'm going to put it over the formula weight of 2 hydrogens, 1 sulfur, and 4 oxygens, which is 98. 98, yeah. When I divide 154 by 98, my calculator says 1.57 moles of H2SO4. Now, I'm going to do the same scale we did on the front, and I'm going to say, all right, I'm going to multiply this by 2 for my hydrogens. That gives me 3.14 moles of hydrogen. I'm going to multiply that by 1 to get me sulfur, which is 1.57 moles of sulfur. And I'm going to multiply it by 4 for oxygen, and that's 6.28 moles of oxygen. Now, I don't want moles of each element. It asks me for grams of each element. So what I'm going to do is I'm going to say X over the formula weight of 1 hydrogen, X over the formula weight of 1 sulfur, and X over the formula weight of 1 oxygen. And then the way that we solve for X is I'm going to multiply 3.14 times 1, gets me 3.14 grams of hydrogen. 1.57 times 32 gets me 50.24 grams of sulfur. And then 6.28 times 16 is going to get me 100.48 grams of oxygen. Awesome. So what I suggest you do is you pause the program and see if you can't answer the next one by yourself. Once you've done that, go ahead and push play and see if you did it correctly. All right, so hopefully you gave it a try. So I want to know how many grams of each element are in this compound. Whoopsies. Whoopsies. I want to know how many grams of each element are in this compound. And so the way that we're going to do this, we cannot compare grams to grams. We have to put them into moles so that we can compare them. So what I'm going to do is I'm going to do 0.45. Sorry, my computer is giving me some issues. 4.5 grams over the formula weight of 3 sodiums, 1 phosphorus, and 4 oxygens. So that's 164 when I add it up, because we're doing moles equal mass over formula weight. When I put that in my calculator, I get 0.027 moles of Na3PO4. So now I have moles of the whole thing. Now I can compare sodium moles to phosphorus moles to oxygen moles because now they're speaking the same language. I'm going to multiply those 0.027 times 3 for my sodium moles, 0.081. I'm going to multiply that by 1 for my phosphorus moles. Why is this jumping all around? I'm sorry. I'm going to multiply it by 4 for my oxygen moles because I have the 4. Now, it didn't want moles of each substance. It wanted mass of each substance. And we know that moles equal mass over formula weight. So I want mass of all of these. And what I need to do is put them over the formula weight of each one. So I have sodium has a formula weight of 23, phosphorus has a formula weight of 31, and oxygen has a formula weight of 16. And we are just doing one of them because we already said how many we have. When I do 0.081 times 23, 1.86 grams of sodium. Multiply these together, 0.84 grams of phosphorus and 1.76 grams of oxygen. All right, let's see if you can pause the program and see if you can answer this next one. All right. So the first thing that we do when we want to know how many grams are in our compound, and we have grams, is we have to put them into moles. So the first thing I'm going to do is I'm going to get mass over formula weight. 310 is the formula weight of 3 calciums at 40 apiece, the mass of 2 phosphorus at 31 apiece, and then 8 oxygens. So hopefully you guys added that all up and got 310. In your calculator, you're going to take 1.73 and divide it by 310, and you're going to get 0.56 moles of calcium phosphate, Ca3PO42. Now, we're going to do the same scale on the front, and we're going to say we are going to multiply this by 3 for our calcium. So 3 times 1.68, excuse me, by 0.56 gives me 1.68. I'm going to multiply it by 2 for phosphorus to give me 1.2 moles of phosphorus. I'm going to multiply it by 8 for oxygen. Okay, and when I do that now, I want to get the mass of these. So I'm going to say moles equal mass over the formula weight of 1 calcium. Moles equal the mass over the formula weight of 1 phosphorus. And moles equal mass over the formula weight of 1 oxygen. And then to figure this out, we're going to multiply these two numbers. That gets you 67.2 grams of calcium. Multiply gets me 34.72 grams of phosphorus. Multiply gets me 71.68 grams of oxygen. So I suggest you go ahead and pause the program if you haven't tried some of these on your own. This one's tricky because it's going to give you 4 elements. Let's see if you can tell me how many grams of each element are in 196 grams of ammonium carbonate. All right, hopefully you gave it a try. So step 1, when you're trying to find grams of each element and you're given grams, you're going to try to figure out how many moles you have first. So I'm going to take my 196 grams and I'm going to put it over the formula weight of 2 nitrogens, 8 hydrogens, 1 carbon, and 3 oxygens. And when you tally that up, you get a formula weight of 96. When I do 196 divided by 96, I get 2.04 moles of ammonium carbonate. Now, a little tricky here. We are going to have 2 nitrogens to figure out how many moles of nitrogen I have. Multiply that by 2. Multiply it by 8 for hydrogens, because there's 8 of them. I'm going to multiply this number by 1 for carbon. And I'll multiply this number by 3 for oxygen. So again, we got to give it in the same language. We got them into moles. Now we can pull it apart by multiplying what we have in moles by its subscript, and we got our moles. The question, though, asks how many grams I have. So what we got is we're going to do moles equal mass over the formula weight of 1 nitrogen, which is 14. Mass over the formula weight of 1 hydrogen, which is 1. Mass over the formula weight of 1 carbon, which is 12. And mass over the formula weight of 1 oxygen, which is 16. So now I'm just going to multiply my moles by my formula weight. And the numbers you should get here are 57.12 grams of nitrogen, 16.32 grams of hydrogen, 24.48 grams of carbon, and 97.92 grams of oxygen. All right, coming to the last one. Pause the program if you haven't tried to do this one yet. Try to do it on your own and then push play. All right. First things, whenever we see grams, we always want to put what we know into moles. So the first thing we're going to do is we are going to take our 5.23 grams. I'm going to do the formula weight of 1 aluminum, 3 nitrogens, and 9 oxygens. So I'm going to get a formula weight of 213. When I divide 5.23 by 213, I get 0.025 moles of aluminum nitrate. Now, we're going to take our skill where we have moles and we want moles, and we're going to multiply this number by 1 for aluminum. We're going to multiply this number by 3 for nitrogen. And we're going to multiply this number by 9 for oxygen. Now, moles equal mass over formula weight, and the question asked for mass of each of these elements. So mass over formula weight of 1 aluminum. I'm going to set these moles equal to mass over the formula weight of 1 nitrogen. I'm going to set these moles equal to mass over the formula weight of 1 oxygen. So what we're going to do is we're going to take our moles times our formula weight, our moles times our formula weight, and our moles times our formula weight. And when you do that, you should get 0.68 grams of aluminum, 1.05 grams of nitrogen, and 3.68 grams of oxygen. All right. Hopefully that helped. If you have any questions, please let me know.